In this video, we're going to use parametric equations to simulate a particle moving along the f equals x squared, f of x equals x squared. So we're going to simulate a particle moving along here. So it starts here. At time equals 0, the particle starts here, and then it moves along here, and then 7 seconds later, it must terminate right here. So we're going to use Desmos to simulate this. I'm going to put a link down in the description to use Desmos. So to use Desmos, click on the link below. So let me try and illustrate this to you. So here the particle starts here. By 7 seconds later, it will move along the path, and then 7 seconds later, it will terminate right here. So we're going to somehow simulate this within Desmos. Okay. So try to do it for yourself. So press pause and have a go. Okay, so to do this, first try and draw this in parametric form. So in parametric form, it will be t comma t squared. So if you punch this into Desmos, hang on, let me just start up a new one. So if you punch in t comma t squared, it will draw the quadratic for you. At the moment, it's from t equals 0 to 1. So let's change this to -2, and then to 3. So this is our aim here. But the thing is, we want the particle to start at t equals 0 to t equals 7. We will make the adjustment later on. So now add your label. Hang on, label. So it starts at -2, 4. So the particle starts there. So let me just put this label in there. So start, and then do the finish label. Finish. So the particle ends at -3, 9, and let me just call it finish. Okay. So now add our slider. So currently, if you just leave it as a and then a squared as our slider, so this will represent our particle. So a will slide back and forth. So now you can slide a back and forth, and the particle will move about. Oh, well, wait there. Our finish is wrong. Our finish should be 3, 9 there. So now it's in the right place. So now we can move about here like this. But the thing is, well, currently is that the particle starts at -2 and then it finishes at 3. But this is not what we want. We want the duration of the journey to last 7 seconds. But at the moment, the duration of the journey is 5 seconds. -2 to 3 would be 5 seconds. But we want it in such a way that when time equals 0, the particle should start at -2, 4, and then 7 seconds later it should finish at 3, 9. But at the moment we're starting at -2, so somehow we need to get it so that it starts at 0, finishes at 7. That's our ultimate aim. But the thing is, if you leave it like this, it won't work, because when a is 0, the time will be 0. And the y location would be 0. It starts at the origin, and then 7 seconds later the particle will be at 7, 49. It will be all the way up there. That's not what we want. We want to somehow terminate right here at 3, 9. You see, currently, if you leave it at 0 and 7, terminates at 7, it won't work. It doesn't work properly. We want it to start at -2, 4. So let me just jump back to this. So when t equals 0, we want the particle to start here, and then 7 seconds later we want the particle to end right here. So if you currently leave it as a squared, it won't work. We need to somehow do it in such a way that when a equals 0, it will start here. By the time a gets to 7, by the time 7 seconds later, it must end up here. So we need to somehow make the adjustments here. Okay, so to do this, get this whole length, because we want, so the duration of the journey is 7 seconds. So what you do is you get this whole length here, you cut it into 7 equal parts. So bear with me. So roughly something like this. Hang on. So get the whole length here, cut it. So that whole length there is 5. Cut it into 7 equal parts. So this number here represents a distance from here to here, and it represents a distance from here to here, and so on. So if you stick a t there, so now one increment of time. So 1 second later, you can see that it jumps to here. So when t equals 2, it jumps 1, 2. When t equals 3, 1, 2, 3. When 1, 2, 3. When t equals 4, it will jump 1, 2, 3, 4. When t equals 7, 1, 2, 3, 4, 5, 6, 7. It will jump to the right place. So by adding this, this t gets multiplied to the top. So by adding this thing here, bear with me, comma, and then 5t over 7 squared. This should almost get us there. So let's try this. Hang on. So let's make this adjustment here. It would be 5a divided by 7 divided by 7, and then it would be 5a divided by 7, and then all squared. Bear with me. And then that should almost get us there. Let's double check. See, that's moving along there. It's moving along there. But if you look at this here, when a equals 0 or when t equals 0, it will start at the origin. But we want to start right here. So let me go back to here. So currently, as it stands, if you leave it as this, hang on, let me just clear this up. So currently, if you leave it at this, when t equals 0, this thing here will be 0. This thing here will be 0. It will start at the origin. And that's not what we want. We want it to start right here. So go back to here. When t, you see this 5t over 7 really allows us to do this. 1 second later, we jump 1 notch. Another second later, we jump another notch, and so on. This 5t over 7 allows us to jump incrementally each step of the way as time goes on. But the thing is, we want it to start right here. So what you do is you take this whole thing here, take away 2. So it should be like this. Hang on. Take away 2. So now normally it would start here. Just drag it back by 2, and then this thing here would be whatever this, because wherever you are, if you square it, it will jump to here. Suppose you're here in the middle of nowhere, square it, it will jump to here. So all you need to do is to get this and then square it. 5t over 7 minus 2, and then just square it. There, this thing here will simulate the particle moving all the way up here. So hang on. So let's make this adjustment here. So whatever that may be, take away 2. So now whatever this may be, bear with me, take away 2. So now it works perfectly. When time is 0, you can see that it starts at -2, 4. By the 7 seconds later, it will end at negative. So by the time it gets to 7, it will end at 3,9. Okay, so that's how you do it. So this is your answer here. Hang on. So this is your answer here. Yeah, so that's pretty much done. But it's a crude way of simulating a situation because it's not very realistic. So something else to note: the particle is not moving at a constant speed. So let me show you this. The particle is not actually moving at a constant speed. it moves fast at first, slows down, and then it speeds up, and it's not actually moving at a constant speed. There's a reason for that. Hang on. If you look at this, 1 second. The point I'm trying to make is that our simulation is quite bad, because 1 second later is here, 1 second later is here, 1 second later is here, another second is here, and so on. We are using this thing here to simulate time. So 1 second later, 1 second later, and so on. So if you look at this thing, hang on. The reason why it's not traveling at a constant speed is because of this. Bear with me. So this is 1 second, and then this is also another second. And then if you look at the distance traveled in 1 second, this distance is really short in comparison to this. And then if you look at this distance here is really short in comparison to this. So it's really a bad simulation. A better simulation would be, well, in the future, you will learn how to work out the arc length from here all the way to here. And then once you've got the arc length, you can cut it up into 7 equal pieces. You can cut up into 7 equal pieces. So now this is a better way of simulating the particle moving along this quadratic. So 1 second, the distance will be the same as the distance over here. So at the moment, because our knowledge is not good, we are just going to do this by cutting this up into 7 equal pieces. Basically, our simulation is not very good. A better way would be to work out the arc length, cut the arc length up into 7 equal pieces, and then simulate it that way. Okay, but for the time being, because you're just starting out with parametric equations, we're just going to leave it as this thing here. Okay.